Hello, everyone. Welcome to this episode of Crops TV. I'm Alison Robertson, a professor and extension crop pathologist in the plant pathology, entomology, and microbiology department here at Iowa State. And this presentation is titled Out Damn Spot, Out, I say. And what we're going to be doing in this episode is we're going to be talking about tar spot and southern rust, and using fungicides to manage those diseases. So first of all, if we think about the 2024 growing season in Iowa, we started off very wet and on the warm side. And then as the season progressed, it became temperatures became normal to warmer, and then also we were drier out in western Iowa as we normally get, and wetter in eastern Iowa. The most prevalent diseases that we saw during the 2024 growing season were tar spot. The first report of that was on the 10th of June, which was the earliest that it has been reported in Iowa. On the 18th of July, we had reports of southern rust, and that was also very early for southern rust in Iowa. And then we also saw common rust this year. So two of the most common questions that I got during the 2024 growing season were, when should I spray and what should I spray in terms of managing tar spot and also southern rust? So what we're going to do in this episode is we have 4 learning objectives. The first is to talk about how we diagnose tar spot and southern rust. Remember, it's very important to make sure that we accurately diagnose a disease so we can manage it better. I also want to touch a little bit on the disease triangle for both of those diseases. We'll also talk about foliar fungicide product efficacy. And I'll tell you now that in 2024, I did find that the newer fungicide products did perform better. And then we'll be talking about foliar fungicide timing and what I found in 2024, that the best return on investment was a single application of fungicide at R1. So let's talk about accurate diagnosis. First, we'll start with tar spot. I'm sure tar spot is familiar to many of you. Remember, what we're looking for is for circular or irregular black spots. They tend to be very small, scattered across the leaf surface. We can see tar spot before tasseling, but it's way more common towards the end of grainful. Severe infections will kill plants, and we can see yield losses of greater than 50%. One of the things when tar spot develops early before tasseling is it can be very hard to find in the canopy because it's usually individual spots just on individual leaves. And a lot of times we can mistake bug poop for tar spot. And so I wanted to talk a little bit about the diagnostic feature that I like to use when I'm looking for tar spot. You may have heard that to distinguish it from bug poop, you want to wipe the surface of the leaf with your finger and a little drop of water and see if you can wipe off that black spot. I don't really like that because sometimes it's difficult to wipe off those black spots. The other thing is that sometimes you can rub so hard that you bruise the leaf, and then it can be kind of hard to tell whether there's a black spot there or not. So what I like to do is I like to look for the black spot on the upper and the lower leaf surface of the plant. And so you can see that in this picture here, that you can see the black spot on the upper leaf surface. If you turn the leaf over and look at the bottom leaf surface, you should be able to see that black spot coming through. And the reason for that is because that black spot is the fungus. The fungus has colonized the leaf, and now it's producing a mass of mycelium into the spore-bearing structure. So it's not a sclerotium, but I know that sclerotia are familiar to a lot of people, and so you could almost think of this like a microsclerotia embedded in the leaf tissue. And so you'll see it on the top and also on the bottom of the leaf tissue. If we take those spots and we section them and put them under the microscope, then what we can see is that black that we're seeing is just a mass of mycelium, of dark mycelium, and embedded in that dark mycelium are these flask-shaped structures. And in those flask-shaped structures are sacs, and those sacs contain the spores. And then what will happen is those spores ooze out of a hole in the top of the flask. And so you might be out in the field when there's a lot of moisture around. And if you look at those spots, you might see this orange gunk on the surface of the tar spots. And that orange gunk contains thousands and thousands of spores. Okay, so let's move on to southern rust and common rust. We saw both of these diseases in 2024, and they can both look very similar, especially if you're colorblind, right? Southern rust tends to be a bright orange in color. Common rust tends to be brick red. But if you're colorblind, that can be hard to distinguish between the two colors. And so what I look for in southern rust is that, remember that southern rust causes these very small, circular orange pustules on the surface of the leaf. They usually, especially early on in the season, you'll just see a cluster of pustules. As the season progresses and the disease gets more severe, then those pustules will cover the entire leaf surface. We usually see southern rust during the reproductive growth stages, so during grainful. And that will become evident why when we talk about the disease triangle. The other thing about southern rust is those pustules will break through on the upper leaf surface. And then when we turn over and look at the underleaf surface, we won't be able to see those pustules. So you might see some light yellow spots or flecks on the bottom of the leaf, but you won't see the rust. Whereas if you look at the top surface, you can see those pustules just exploding through the epidermis of the leaf. If we look at common rust, right, so common rust tends to be that a darker orange or a brick red. A lot of times those lesions will look kind of rectangular. And we'll see those lesions breaking through, or those pustules breaking through the leaf surface on the upper leaf surface, and then also on the underside of the leaf surface. We normally see common rust during those early vegetative growth stages. It's not unusual to start seeing common rust around about V6. And then once we get to tassel, we may see common rust occurring afterwards, but it's usually not that common. And because of that, yield losses from this disease are very rare. Sometimes when I'm out in the field, I have to do a double take when I see these rectangular lesions, just to double check whether I'm looking at gray leaf spot or not. And so this picture here shows you those rectangular lesions that look a lot like gray leaf spot, right? But if you hold that leaf up to the light, you'll see these blisters within that lesion, and those blisters are the start of those pustules as they start to burst and come through the epidermis of that leaf. So with gray leaf spot, the spores are produced very differently. They come out of the stomata of the leaf, and so you wouldn't see blisters in a gray leaf spot lesion. Okay, so we've talked about accurate diagnosis. So let's just talk about the disease triangle for each of these diseases. It's important to understand what are the conditions that cause this disease to develop, because by understanding that, we can then manage the diseases better. So if we look at tar spot, here's the tar spot disease triangle. You'll remember that it's caused by the fungus Phylochoromatus, and that fungus is able to survive in our residue over the winter. And so early in the spring, that residue, the fungus in that residue will start to produce spores, and those spores will be blown through the field, infect new plants, infect neighboring plants, infect, come from other states, etc. We know that hybrids vary in their susceptibility to disease, and corn breeders have done a great job over the past few years of introducing hybrids that have better tolerance to the disease, and that information is available in your seed catalogs. So if you're concerned about tar spot, it's always the best place to start is with your host, right? And planting a hybrid that has some tolerance to the disease. What about the environmental conditions? So this is work or these conditions we've worked out from research that was done as part of the National Predictive Modeling Tool Initiative, which is an initiative that's funded through Congress since 2020. And in that initiative, there are 10 states working on corn, and we set up small plot trials at different locations within our states, and we collect information on how disease is developing throughout the growing season and what pathogen populations are doing, and then also the weather. And from that, very recently, Damon Smith's lab was able to develop a model for tar spot. And what we learned in that model is that, first of all, we need a mean daily temperature of 68 to 75 Fahrenheit for 30 days. That favors tar spot. Once we get outside those temperatures, tar spot development is slower. And then also that we need relative humidity less than 90% for 2 to 3 weeks. And those factors will play a role in how severe tar spot. If you're interested in reading more about how the weather affects tar spot, you can go to the Crop Protection Network, and there is an article there that's available. This QR code will also link you to that article. So what about southern rust and common rust? So they're both, the rusts are caused by Puccinia species. So we have Puccinia polysora causing southern rust, Puccinia sorgi causing common rust. And one thing about the rust is they cannot survive in residue. All rusts can only survive on living green tissue. And so these pathogens will survive down in the south, in Central America, the southern states on green tissue. And then what will happen is as the growing season starts down there in the south, they'll then spread to corn and then build up inoculum and then gradually move up here into the Midwest. There is resistance available in hybrids to the rusts. I'm not sure that it's always available in company catalogs, and we certainly don't worry about it for common rust. But for southern rust, there is resistance. However, a lot of times the pathogen has already evolved to overcome that resistance, and so we rely more on partial resistance or field tolerance. When we look at the environmental conditions that we need, so both of the rusts require those wet periods for those spores to form and for infection to occur, but then we also need dry periods which allow those spores just to be lifted off that leaf and spread through the field much earlier. The biggest difference between these two diseases is the temperature. Southern rust prefers very warm conditions, whereas common rust prefers very cool conditions. And so you'll remember that I said that southern rust is more common during grainful period, and common rust is more common during vegetative stages, and a lot of time that has to do with the temperature, right? So early in the growing season, our temperatures are too cool for southern rust. Plus, it has to take time to get here from the south. And once we get into the grainful period, then our temperatures are too warm for the common rust. And also, as corn gets into later growth stages, it gets more resistant to common rust anyway, and that's something called adult plant resistance. So hurricanes, what do hurricanes have to do with disease? Well, this is a map from NOAA just showing the hurricanes that occurred in 2024 and where they tracked. And I want us to focus on Hurricane Beryl, which is the line there, that's number 2, starting out in the mid-Atlantic and then making its way to Texas and up the east coast of the U.S. So this is probably a better picture, just showing you. So Beryl was the earliest Category 4 hurricane on record. It made landfall in Texas on the 8th of July. And then it was a huge hurricane and very strong. And so there were these remnants of very heavy rain that kind of moved out from that hurricane across the Midwest and up the northeast coast of the U.S. So this is a slide from Madeline Wustenberg, the Ag Climatology Extension Specialist here at Iowa State. And so she very kindly, when I approached her about this, she shared this data with me. But so Tropical Storm Beryl, as it hit landfall, affected Iowa. So what we can see here is that on the 8th of July, first of all, we had pretty strong winds coming from the south, about 5 to 10 knots. But also, if we look at the temperature in southwest and central Iowa, you'll see it was between 75 and 81 degrees. And we had very high dew points. And those conditions continued for the next few days. And if we look at the southern rust reports that were made in Iowa, on the 18th of July, we had our first report of southern rust in central Iowa. And then there afterwards, we just got more and more reports of southern rust occurring. So I've been here, 2024 was my 21st growing season in Iowa, and I have never seen as much southern rust as we did in 2024 compared to the other 20 years that I've been here in Iowa. So we really did get southern rust coming in earlier and becoming more and more severe. I'll show you some data about just how severe it got at some of my locations where I had trials. But it made me wonder about the hurricanes, because it's not that we had more hurricanes in 2024, it was just that the hurricanes were more intense. And because they were more intense, we had more of these remnants. And so I can't help but wonder if Hurricane Beryl was very effective and efficient at bringing those southern rust spores up into Iowa. And therefore, we got this early development of southern rust that was fueled by good temperatures for its development, and then also high relative humidity, so the moisture that was needed. And so it's hard to say where we go from here, but if we continue to have more intense hurricanes and more of these remnants spinning out into the Midwest, are we going to start to see more southern rust up here in Iowa? And is this another disease that we're going to have to manage? And those are just things that I wonder about. And I guess in the next 10 years of my career, well, I'll be able to watch that and see. Okay, so that's the disease triangle. So let's talk about foliar fungicide product efficacy. So many of you are familiar with my fungicide trials that I do around the state every year. The red dots show where I do these, and the green boxes show the date when those trials were planted and then the date when they were harvested. And so I like to plant at different locations across the state because I want to hedge my bets at getting disease. Unlike most of you out there, I do want disease in my trials. If I'm going to collect data on when to spray and what's the best thing to spray, I need to have disease to be able to tell that. And so I've put the diseases that occurred on there. So you can see in western Iowa at the farms there, we had both southern rust and tar spot. At the northern research farm in near Kanawha, we had only southern rust. At the central farms, we had southern rust and tar spot. Down in southeast Iowa, a lot of tar spot, no southern rust in my trial. And then up at the Nashua research farm, barely any disease up there. So that was a little disappointing from my point of view. Okay, the products that I tested in these fungicide trials, I refer to them as the cardinal fungicide trials. We had 8 products, all applied at their standard rates. Apart from Valtima, which we tested at a 7 and a 10 ounce rate. All of the products were applied at an R1 timing, except for that Valtima, and that was applied at V12 and R1. These were all applied with either a ground rig or a knapsack application. The whole field would have been at R1 when we applied them. And I should mention that at the Armstrong Research Farm down in southwest Iowa, we were a little late there due to poor communication on my part. And so products getting late down there. But so those products were applied at R3 there. What I do in these trials is I go out and I assess the ear leaf severity at around about R5, and then we also collect yield data. So all of this data that I'm going to share with you now can be found in my field notes, and you should have received a link to that in your registration. And so there's a lot of data, kind of complicated, but hopefully if you want to go back and look this over, you can download my disease note. Okay, so we're going to look at tar spot first. So we have tar spot severity on the vertical axis. I have my products along the x-axis in alphabetical order. So remember, everything was applied at R1 unless I've indicated on that x-axis. And we had tar spot at 4 farms. So in central Iowa, we didn't detect an effect of product on tar spot. But at the Armstrong, which is in southwest Iowa, the Northwest Research Farm, and the Southeast Research Farm, we did detect differences among the products in tar spot control. So here's our check. You can see that the amount of tar spot that we had among the locations varied. So in central Iowa at R5, we had about 2% severity on the ear leaf, whereas down in southeast Iowa, we had about 15% severity. What does 2 and 15% severity look like? These are some cartoons that I took from the Crop Protection Network from their disease severity estimation tool. So this is something that we use every year in my lab just to key in our eyes so that we can assess disease effectively. So what I've done is I've starred the bars that were significantly different from the control. So in other words, these products statistically reduced tar spot compared to the check. And so you'll see that at 3 of the 3 locations where we detected a difference, Delara Complete, Moravis Neo, and Valtima reduced the amount of tar spot severity. So the fact that that was consistent across the locations gives me a lot of confidence that those products are very good at reducing tar spot severity. Approach Prima did well at a couple of locations, not so well down at southeast Iowa. One of the reasons for that may have been just because of the very high disease severity. But time will tell, right? I believe that out in the Eastern Corn Belt, Darcy, Marty, Damon, when they've tested Approach Prima, they've usually had pretty good results of that against tar spot. Okay, and then when we look at the Valtima, there was no difference in disease control between the 7 ounce and the 10 ounce rate, and no difference between an application at around about V14 versus that R1 application. So at Southern Rust, this data's laid out exactly the same way, but remember we're looking at different farms now. So now we have the pink bar for the Northern Research Farm near Kanawha. We've lost that light blue bar from Crawfordsville. At all of these locations, we detected an effect of fungicide on that Southern Rust. So if we look at the check, Southern Rust severity ranged from 3% at the Central Iowa Farm all the way up to 9% at Armstrong in southwest Iowa. So this is what 3% severity and 9% severity looks like on the ear leaf. And if we look at which products did the best, so Approach Primo, Miravis Neo, and Veltima at R1 significantly reduced the amount of southern rust compared to the check at all 4 locations where we had disease. Delaro Pro did pretty well at 3 of the 4 locations, and then Adastrio and Veltima at V14 did well at 2 locations. 7 ounces of Veltima was just as good at reducing disease as 10 ounces of Veltima, but I would say, just based on this data, that that application at R1 was better at controlling the southern rust than that application at V14. And that probably makes sense, right? If you think in terms of when southern rust arrived here in the middle of July, we would have been at around about R1. Okay, so as is usual in my trials, I don't detect differences in yield among the treatments. But if we think about this, if we have less disease on the leaf, we should have more leaf area to photosynthesize and to fill that grain, right? And therefore, if we can reduce severity, we should have better yields because we're protecting that yield. So I did do some correlation analysis. And so here we have yield response on the y-axis compared to disease suppression on the x-axis at the Southwest Research Farm and the Southeast Research Farm for both tar spot and southern rust. And so what you can see is that there's a positive relationship between disease suppression and yield response. So in other words, if you reduce disease, you protect your yield and you have greater yields. Okay, so as you know, it certainly looked like from my trial that the newer products did much better against the diseases. But remember that I had pretty high disease severity in my trials. And so for those of you in an area, for example, Southeast Iowa, where you have a lot more inoculum and better conditions for disease development, more moisture, it might be worth considering some of those newer products. Whereas if you're in Northwest Iowa, where there's less inoculum, tends to be drier, we tend to have lower disease severity there. You might be able to get away with an older product rather than going with a newer product. Okay, so I wanted to point out a couple of tools or publications that are available from the Crop Protection Network. The fungicide efficacy tool was brand new in January 2024. And this is a tool where you can enter your crop, what disease you want to manage, if you're interested in particular modes of actions of fungicides, and you can search and find out what fungicides are rated excellent or very good or even poor for managing that disease. So that's a great tool that's available for you. That tool is based on data that comes from this PDF publication that is also available at the Crop Protection Network, the fungicide efficacy for control of foliar diseases. And I know right now we are working on updating that publication. So that publication gets updated every year with feedback from corn pathologists across the US. And it's based on their fungicide, on our fungicide trials that we do. And we then give those ratings to each of those fungicides that are registered. Okay, so let's talk about foliar fungicide timing. So the first trial that I want to talk about is a trial that was done by Cody Schneider, who's the farm manager down at the Southeast Research Farm near Crawfordsville. And he did this work as part of his master's degree and really got some very neat data. And so that's what I want to show you today. So once again, tar spot severity on that y-axis. Along the bottom, what you'll see is the times that he applied the fungicide. So there's a no fungicide control, and then there's a single application at V6, V12, R1, and R3. And then Cody also did double applications at V12 and R3, and then V6 and R1. You'll also notice that there's a little title there that says task spot severity or task severity of the check at R3. And so he collected data at R3 on the control to find out how much task spot was there. He had observed task spot at R1 when he sprayed, but it was literally a few single spots on a few leaves. And so I think that this gives you a very nice idea of how task spot developed in that trial. So he did this in a corn on corn field and a corn on soybean field. So if we look at the corn on corn field, first of all, if we look at the check, and I'm just going to focus on the ear leaf for this, but task spot severity was 10%, so that's shown in that cartoon there. And what you'll see is that an application at R1 was most effective at reducing the disease on the ear leaf, and those double applications also were very effective at reducing the disease on the ear leaf. But note, because they have the same letter, that means that they're not statistically different. So that R1 was just as good at reducing task spot on the ear leaf as those double applications. If we look at the corn on soybean, we see exactly the same. So first of all, we have more task spot in this trial, so we're over 16% severity. But once again, even though those double applications are reducing disease the most, they're not different from that R1 application on that ear leaf. If we look at the yield data with the corn on corn, we didn't see an effect of fungicide on the yields, or at least it wasn't statistical. Certainly looks like we got better yield, but we couldn't detect that statistically. But in the corn on soybean, Cody was able to detect differences, and so we had greater yields with applications of fungicides at V12, R1, R3, and the double applications. But those yields were not different among those fungicide timings. So that was Cody's research done in 2022. This year we worked with Whiffle's hybrids, and we had a trial out in the Muscatine Research Farm, the Iowa Research Farm out there. Some of you will know that this research farm has irrigation, so this trial was irrigated. And in this trial, we looked at fungicide timing during the grain fill period. So we have an untreated control, an application at R1. Then we have an application 2 weeks after R1, which would have been around about growth stage R2, getting into growth stage R3, kind of end of pollination. Those silks have just turned brown, so brown silk, if you want to use that terminology. Then we had a double application of R1 and 2 weeks after R1, a single application at 5 weeks after R1, which would have been around about dent, and then a double application with 2 weeks after R1, so end of pollination, and then around about dent. And this was all using Veltima. So first of all, if we look at the control, or look at how much task spot we had, around about 23% task spot on the ear leaf at R5, so really good disease pressure from task spot there. The best treatment at reducing the amount of task spot was a double application at R1 and 2 weeks later. But that single application at R1 was a pretty close second at reducing disease. So this was on the ear leaf. So what about in the upper canopy? We see very similar data. So we had about 20% disease severity in the upper canopy. That double application reduced disease the most, but that R1 application also did a pretty good job at controlling disease. When we look at the yields, we did get the greatest yield, statistically better yield than the control at that R1 plus that 2 weeks later, so that double application. But you'll note that the single application at R1 or at brown silk, or that double application at brown silk plus 5 weeks later at dent, were not statistically different from that double application of R1 plus 2 weeks. So that was in Muscatine at the ISU Heinz Farm, which is here in central Iowa. We got some very nice data on southern rust severity. So the Heinz Farm has irrigation. It's had overhead irrigation, a pivot for the last couple of years. And so there we put in a trial with BASF to look at fungicide timing. And like I said, very good southern rust severity. This was at R4, maybe just getting into R5, that dent stage, but we had almost 50% disease severity from southern rust there. And then we looked at 7-ounce and 10-ounce rate of Valtema at R1, a double application of 7 ounces at V14 and 21 days later, which would have probably been around about getting into R2, and then a 7-ounce application at R1 plus 21 days later. And you can see that Valtema did a fantastic job at reducing disease severity there under irrigation. So we're looking at about 5 to 7% disease severity among those treatments. And we probably didn't detect a difference in the treatments because that control severity is so high. And so what I did was I took that control out, reanalyzed the data, and now we can see the double application at V14 and 21 days was not as good at reducing southern rust compared to that application at R1 plus 21 days later. But the single applications at R1 were just as good as those double application or the double application at R1 and 21 days later. And we see no difference between the 7-ounce and the 10-ounce. Okay, so we look at the yield, no statistical differences in the yield, and frankly, the yields are a little bit odd. I mean, one of the double application gives us very good yield. The other double application does not give us good yield, but no differences in yield among those timings. Based on these data, I would say that yes, while we may decrease disease a little bit more with a double application of fungicide, it's usually not different from that single application at R1. And the other thing is that we don't really see a difference in yield as well. And so if you think in terms of return on investment, what are you going to get the better return on investment from? A single application or a double application? A single application, right? You're only paying for that fungicide once. And another tool that has just been added to the Crop Protection Network, I want to say in December, is the Corn Fungicide Return on Investment Calculator. And so once again, this QR code should take you to that. But this is a calculator that you can use to input your disease that you see in the field, what you expect your yield to be, what you expect, your price that you expect to get for the grain, and then just to run those numbers and see whether it's worth spraying a fungicide or not. Are you going to get a return on investment? So let's summarize what we've learned in this episode today. Accurate diagnosis is very important. So remember for tar spot, you're looking for those black irregular raised spots on the top and undersurface of the leaf. With southern rust, those are very small circular pustules that are usually occur in clusters, but then eventually will take over the whole leaf. You're only going to see those on the top of the leaf. Whereas with common rust, that's more brick red spots. They tend to be more rectangular, and you'll see them on both the top and the bottom surfaces. If we think about the disease triangle, remember that tar spot and common rust both prefer cooler conditions. And while tar spot survives in the residue, southern rust and the common rust both survive down in central America and also in the southern US, so we have to wait for them to get up to us here in the Midwest. We didn't talk about latent periods, but the latent period is from the time of infection until the time that we're producing spores. And so what you'll see is that for tar spot, we have a very long latent period, about 40 days before an infection leads to the production of spores. Whereas with the rusts, we have a very short latent period. And so that means we'll get a lot of disease cycles with the rusts and less disease cycles with the tar spot. When we talk about product efficacy, so for tar spot and southern rust under high disease pressure, I do think that the newer products are going to be more effective than the older products or generic products that you might want to use. So that's something that should be considered when you're thinking about whether you want to spray a fungicide. And don't forget those cool tools that are available from the Crop Protection Network that can help you with your decision. In terms of timing of application for both tar spot and southern rust, applications at R1 were very effective at reducing disease, and they were and a double application was not necessarily different at reducing disease. And then also the yield of that single application at R1 was not different from the double applications. And so therefore, that alone tells you that a single application is going to give you a better return on investment than your double application. So I want to thank you for joining me today. I want to thank you for supporting Crops TV. If you do have any questions or comments related to this episode, please feel free to reach out to me. Send me an email. I'm pretty good with replying to emails. And if you want to follow me on X and see what I'm seeing out there in the field, that's my handle there. But thank you for being here today.